Problem. The goal of this lab is to determine 1. The time t a hopper is in the air, and 2. The initial velocity of the hopper. The materials necessary for this experiment are 1 large hopper, 1 small hopper, and 1 meter stick. The lab procedure is as follows. 1. Invert the hopper. 2. Place the hopper on the table next to your partner holding a meter stick. And 3. Using a ruler, determine the maximum height the hopper reaches. Images describing the steps have been provided. This process should be repeated 5 times for both the small and the large hopper. A data table like the table shown has been provided by your teacher. The data table has spots for all 5 trials regarding the maximum height of both the large and the small hopper. The last row details the average height which will be necessary for the analysis questions. Here's an example of a filled out table with experimental values. Analysis question 1. What is the speed of the hopper when it reaches the highest point of its trajectory? The speed of the hopper at the highest point of its trajectory will be 0 meters per second. This is because the object is in the transition of changing the direction of its velocity from upwards to downwards. Using the 3 kinematics equations, calculate the initial velocity of each hopper using the average height. The third kinematics equation will be used in this problem. Acceleration will be equal in magnitude to gravity, the final velocity will be 0, and the change in height will be 0.496 meters as calculated in the experimental table. The initial velocity of the large hopper is calculated to be 3.1 meters per second from equation manipulation. The methodology of finding the initial velocity of the small hopper is the same as the large hopper. The initial velocity of the small hopper is calculated to be 2.6 meters per second. Find the time each hopper was moving up in the air using the average height. The first kinematics equation will be used in this problem. Final velocity will be equal to 0 meters per second, initial velocity will be equal to 3.1 meters per second, and acceleration will be equal to gravity, which is equal to negative 9.8 meters per second squared. Through variable manipulation, we get that t is equal to v naught over g, which is 0.3 meters per second. Thank you. The interpretation and application questions should be answered as a class. Thank you for your participation in this online lab. See you next time.